Okay, so for this what I'm going to talk about is um, I'm going to make a tool that's entirely for representational purposes. And I'm invoking a little bit this kind of foam model presentation or table in which many iterations are placed in comparison to each other so that you can kind of compare and contrast and display your process. On one hand, it's a very simple tool and conceptually. It's a tool to essentially bake your progress, but it's also a very helpful tool in terms of representation. And since this set of videos is entirely about representation or harnessing the power of representation within the creation of tools, I think it's especially relevant and kind of a great base with which you can work and use your tools. Okay, so I'm starting from the spider sack example, which is an example that uses geometry to kind of carve out two volumes from each other, do some analyses. But really, what I want to do is to create a way in which I can, work with a lot of iterations. Because the problem with this is that, I can do a lot of different versions, but I don't know exactly what I've made, and it'd be great to compare and contrast. So what I want to do is I want to make a button, and within the interface of Grasshopper or Rhino, and if I click on the button, I want to be able to have both the geometry and any analysis placed on a table. And if I click on another button, more geometry will be placed on a table. But I don't want to have to go and move anything or fiddle around with anything. I just want to be able to kind of play around here, make place, make place, make place, and then later go to this table and kind of see what exactly I've been doing. Alternately, what I could also do is I could, in fact, have these objects already placed on a table. So I could get rid of the city model here, and I can kind of move this geometry, place it, and then move to another portion of the table, place it. And that's actually the version I'm going to be showing here. It involves a little bit more interesting work with the camera, but I think it'll be very helpful, and it'll also kind of show you an insight into how you can use the Flounder camera control as a tool to kind of manipulate geometry in new ways. Because here what you're seeing is I'm looking at the same point in space, I'm looking at the same geometry and just hiding and showing things. In this example, I'm actually going to be showing two different locations in space that are separate in separate areas but are made to look similar. That's a little vague, so let's actually go on to executing what I'm talking about. So first of all, I'm going to write some pseudocode. Again, I think this is great practice. And to think about what I want to do. So I want to be able to define a table area. And then I want to say, okay, define kind of the spacing of my table. Now this, may be random. This may be automatic, but let's just say that I can define a spacing and it can define a grid. So define spacing for my table to create a grid. And I also want to then display. I want to display the geometry or analysis or the tool results on the table. I want to have a button that bakes geometry. Create button that bakes geometry. And let's see, I want to define a table, define a spacing, define the tool results on the table, and to create a button that bakes geometry. But moreover, I want to display the tool results on the table, moving the results around like separate objects. Great. So this is a little vague, but we'll get into exactly what that means in a second. So first of all, I want to define a table. Okay, so I'm in the spider sack world, right? And I'm going to, for the time being, bring up the viewport view so I can see what's going on. So I'm in the spider sack world, and I'm actually going to make a table way far away over here. And as you'll see later, it doesn't really matter where the table is. It just matters that I can't see it. So here's my table, let's say. And just to be tongue-in-cheek, I will make an actual table. Or I'll just make a box. This will just be a podium, perhaps. Or actually, you know what? I will actually make a table. So I'm actually going to make a table. It's a little bit tongue-in-cheek, but part of the point I'm trying to make is that the representation of what the tool does is very important, in some ways will affect the way you design. So creating this table on which we have our geometry is actually a good way not just to showcase what we've done, but also while we're designing to tell us more about what we design and how we can design. In the way that any pinup or any crit in general in Studio is a good way to influence design. It's not just a representation, or it's not just a one unidirectional expression of information. It's a way to kind of resynthesize information. So I've created a table, and the table is just for display purposes, really. And I've also created this curve, and I've created a layer called table. And what I'm really going to use is I'm going to grab this top surface, or this curve, with a pipeline object, geometry pipeline, and I'm going to say grab the layer table. I'll specify that I'm using curves. So when I pipe it into a geometry component, let's see. Oh, I think table is in all caps. You can see I'm grabbing the table. That's great. So in some way, that's akin to part of the first process in our pseudocode, which is to define a table and define spacing for my table to create a grid. Display tool results on the table, and using that together with the base geometry. Now I'm actually going to jump ahead because it's not always necessary to go in order of the pseudocode. I'm going to go into the last one, and I'm going to talk about what it means to display the tool results, so that you can kind of see what exactly I'm talking about when I'm talking about using a table or a pinup table. So if I go back, and I'm going to turn the camera syncing on by turning on the timer. If you go back to this example of using the camera, using the Flounder camera, I want to emphasize again how effective having this split camera is. It's not just a way to show information. It actually lets you use Grasshopper like a tool, because you're not hiding and showing preview objects or custom preview components. You can actually edit geometry while you're looking at the end effects. And I noticed that some of you might have been using only one view without implementing the split view, and I'd encourage you to try to implement it because it actually does change your workflow. In any case, the Sync Flounder camera, as you know, syncs between two views, and it syncs between it grabs information from here and implements it into here. And we can also replicate this functionality by using the Flounder components that I've created. There's also two other components. There's get camera and set camera. And these two components, you can chain them together to do the same thing. So I'm actually going to delete this component here and try to implement this again. So what getFlounderCamera does is, given a Boolean and given the name of a viewport, it'll give you this information on the right, which is the location of the camera, the target of the camera, the lens of the camera, the focal length, and up. The location is where you are, so it's the location of the camera from your vantage point. The target is what you're looking at, which is, you can see the dot here. It's almost always in the center of the screen because it's the center of what you're looking at. The focal length is, if you know anything about photography, it's kind of it's modeling. It's using the focal length of kind of 35mm cameras as a model. The long and short of it is that the larger the focal length, the more orthogonal or the more axonometric-like objects will appear. If I use dolly zoom in Rhino to change the perspective and to kind of have these distortions, the focal length will probably become very small. And I can, if I plug the timer into here, you can see that the focal length is like 1.25 now. So the smaller the focal length, the more distorted or the more kind of wide angle you get. And the up is the up direction of the camera. Now, sync flounder camera is the opposite of that, as you can imagine. I'm going to connect this to the timer, so this also updates. If I give it a Boolean, and if I give it a viewpoint name, and if I plug in all of these variables into here, then it'll take this information and sync this viewport to match this information. So now that I've taken the information from model view and plugged it into the camera information from render view, you can see it's together. And this is kind of replicating the functionality of the sync camera, flounder camera up above. Now I think there's a small bug in that this appears to say sync flounder camera. It really means put flounder camera, and I'll fix that in a future release. Now one thing I want to talk about is I can also, and this is the point of this tutorial, is I can also move where the camera is pointing at and where the camera is looking at from in order to sync the movement of the viewport or sync the movement of the interface while looking at a different location. And I'll show you what that means. Let's say I'm going to move everything 100 units in the X direction, and I'm going to plug this into a move component. I can move the location 100 units to the right, and I can plug it into here. And I can also move what it's looking at 100 units in the X direction and plug it into the target. And what this does is you can notice that as I move this point, my camera on the right-hand side shifts, right? But if I orbit, I'm orbiting around this new point on the right. And so I'm actually going to modify my slider here to say 500 so that I can move it a little bit more so you can get an even better understanding of what I'm talking about. So you notice that I'm on the right hand side, I'm orbiting around this new point even though my geometry is around the old point. Now the reason why this is interesting is that the camera is not only what I have to move. I can in fact move this geometry over here. And I can also move the mesh over here too for many reasons. So right now everything is being previewed based off of this geometry. And if I move this geometry also in the X direction by 215 units, then you would imagine that this geometry that I've calculated is moved to this new point. So I'm going to do that. And now you can see that if I hide this, all the new geometry I've made is instantiated over here. So if I move this around, it appears as if I'm moving around the same geometry, but really in XYZ space, it's in a different location. It's over here. Looks like there's a little bug I'm going to fix. I think it's because the custom preview object is actually showing the preview in the wrong location. I think I'm right. Or no, it's showing it in the right direction, but it should be showing it over here and not moved. So I'm just going to go in and edit that. Excellent, so I fixed it. So now what does this mean? It means that the points, I'm selecting these points, but really they're over here. But what I'm looking at and what I'm orbiting around, and I'm actually also going to hide the city just for a moment, which I think is these items. No. Okay, there are these items down here. I'm actually going to hide this preview object. Okay, so if I'm rotating around, it looks like nothing has changed, but when I highlight these objects, these points are actually in XYZ space in a different location, or this geometry has been moved, but it feels like it hasn't. And this is important because instead of having all this geometry move in the X direction by this many units, I can actually move them onto the table. I can move them in a far off location. It'll still feel the same, yet I'll be operating on a different surface, so I can, which then lets me able to make copies or bake geometry. So by now you should be able to understand that, and I'm going to show you this in a top view, in a plan view. So if I highlight these points, see these are, what the points I'm highlighting are around here, but the geometry that I've created is offset. I hope that's pretty clear. Okay, great. So now what I'm going to do is I want to do a similar, the same operation, but instead of moving this to an arbitrary area or an arbitrary point, I actually want to move this onto the table, somewhere onto the table. So this is great, and I'm actually going to pause this, and this is kind of the displaying the tool results portion. So I'm going to pause this, and I'm going to go back to creating a grid upon the table. And I apologize for jumping around, but I hope you can. I think it's important to understand that I've created this aspect and I've created this aspect. So I'm going to actually move my pseudocode around to match. And now it's kind of a way of growing in both directions to try to figure out this out so that I can use this object that comes later in order to connect with this object or component that comes earlier. So I'm going to go back to my table, which is a little hard to find, but it's out over here. Excellent. And if you remember, I had the pipeline grab the surface of the table. It looks like there's another curve here that I'm going to delete. Great. So what I'm going to do is I'm going to define my spacing for a table to create a grid. So there's a few ways I can do this. I can divide a surface, and I'm actually going to use this. So this divide surface divides it into U and V surfaces, and the U and V is that each surface has an internal kind of orientation, so U and V axis, and it divides them along with these number of segments. Now I don't want an arbitrary number of segments. I want to get the dimensions of the surface and get a point grid of a good number of size, an ideal size. So I'm actually going to grab the dimensions of a surface. And this says, okay, your surface in one direction is 710, the other direction is 1100. And I'm also going to make a resolution slider. So maybe my resolution is like 80. And I'm going to divide each dimension by 80, and which gives me in one direction 8.88 and in another direction 13.85. Now I can plug these directly into divide, and Grasshopper is smart enough that because it knows I'm expecting an integer, it'll round up. Around for me. So depending on the resolution, I can change how many points I want. This is great. The other fun thing I could do, or the other smart thing I could do, is that I could say, okay, well, this is all great, but I don't want, because if I'm using the analogy of a pinup table, I don't want my objects to be too close to the edge. So what I'm going to do is I could either think about removing one edge or all the points around an edge, which I could find the points closest to the edge and delete them. Or I could also do a very fast thing, is I could modify the initial line that's being used to instantiate the points. So I'm going to say offset. I'm going to grab that curve and offset by a little bit. Let's see. I'm going to offset it in the negative direction. So I could either modify this to be negative, or I could just use the negative component. Okay, so now I can say, okay, only make points inside of this. So I get an offset from the edges of the table. And then I can use this then to subdivide and understand the dimensions of. So that's pretty convenient. And let's say that's my kind of rhythm, my spacing. So great. Now I've defined spacing for my table to create a grid, which is excellent. And what I'm going to do is I can cluster this, but I can also group this so that I can visually kind of separate these out. And I'm going to hold Alt and move it out so I can kind of stretch this separately so that the pseudocode makes more sense. So I've created a grid, and I'm going to grab this geometry. And I talked a little bit about trees earlier, but I'm also going to just flatten this component so that I just get one long list. I don't want any kind of complications. Okay, great. So, and just for the sake of connecting these things together, this process together, because I've created a grid and I now want to display the tool results. But I want to display the tool results on one point, and I want to continue along the other points. Now, in good practice in Grasshopper is if you're dealing with a lot of data and you're trying out something for the first time, it's good to try it out for the first iteration with one item instead of trying to do everything at once. You try it out with one item. So right now I'm just using this list item component to just choose one point. And now I'm going to try this aspect of displaying the tool results on the table. Now, I already have done this earlier, right? In fact, it's right around here. But what this does is this has moved our interface or the analyzed geometry in the x direction. We want to do something similar, but instead of moving it in the x direction, we want to say, okay, actually we want to move it from the location of the interface to one of these points, specifically this point. Now, how do we do that? First of all, what we can do is we can figure out where we're looking from, and where this is starting from, where this is going to, get a vector between the two, and plug that vector instead of this x vector into all the move components. So then the first question is, okay, where are we looking from, or what's our source? So this is our initial geometry, and if I do a show, I just showed the hidden geometry inside of it. I could perhaps go into plan view or top view and inscribe a rough site. I'm just doing this arbitrarily, but you may actually have a site. And just to make sure that, what's actually happened is this is on the table layer, so we don't want that to happen. I'm just going to put this in the city model layer, actually. Great. And I'm going to also use set points to make sure that it's entirely flat, so all the z values are here. Okay, excellent. So if this is my site, if this is what I'm using for my site, then it does look like many of this building that I've created is a little bit floating in midair. But I'm going to get I'm going to designate a center point for this site. In fact, or actually, I'm going to grab this geometry and enter it into Grasshopper. I'm going to use the area component to get the, area component to find the centroid of that site. Now, what I'm essentially doing is I'm just creating a stable site from which this entire geometry will be copied to. So now I have the geometry from, and I have the point from which everything is copied. And then I'm going to use vector 2 points because I'm going to copy it from here to the table over here. And that movement vector is really this value. And if I say, okay, great, this is the value I want. Now I want to actually move my analysis, again, instead of moving it in the x direction, I want to move it along the lines of this vector, or using this vector. So I'm going to plug it into everything I need, or everything that x used to be pointing into. Delete that. And you can already see that it's worked to an extent. So this geometry has moved over here. And I'm actually going to take this, I'm going to lock it, so I don't accidentally select it. And I'm going to select, I'm going to select my points and kind of move it over. So great, now you can see that it's been moved over here. And if I turn the camera syncs back on, even my camera is rotating around the table, which is incredibly convenient. And also incredibly fun. And I'm going to also lock this geometry. In fact, instead of locking, what I can do is I can go back to my preview object, and this time show this geometry, but not in the render view, in the model view. Excellent. So I'm going to make this transparent. So what I can do is, or what I'm doing right now is I'm placing, on the left-hand side, I'm modeling new building. On the right hand side, it's being placed on a table. So that's great. This is actually a lot of fun. And I'm going to hide the things that are not relevant to me. So a lot of this geometry. I am, however, going to show the dots just for right now, so I know where my geometry is going. Now the last thing I want to do, and the core functionality is, this is great, but I also want it to be able to bake and go over to the next point. And this is going to be a little bit of a hoop. I'm going to disable the camera syncing right now because it's slowing down my computer. Okay. This is a little bit of a hoop one has to jump through. What I'm going to use is I'm going to use the button component. And the button, if I show you a panel, when I hold it down, it goes to true. When I let go of the mouse button, it reverts to false. I'm going to call this button the bake button, or the iterate button actually. And I'm going to publish it to the remote panel, which can do with buttons, so that if I go to view and show the remote panel, slide it into Grasshopper, you can see I have the iterate button over here. I'm also going to make it into its own group so that, visually we know this is like an important thing. So how do I use this to iterate over this grid? Well, there's this other component called data recorder. So if you give it a bunch of data, it'll record that data. And this means that it's recording. I can turn it off, I can turn it on, and this can clear it. If I click, it'll just keep on recording data, and you can see that if I put a slider into it, it just adds onto the end of this data. So I just cleared it. If I move, it'll just keep on recording the data, which is convenient. But we don't want a slider, we want the button. And another thing is that if you click on it, you notice that you get both a true and a false. Now one thing we could do is we could say, okay, I just want to capture how many times it's happened, I've clicked on it, and how many times I've gotten a true. So one thing I could do actually is I could say equals, when is it equal true? Boolean. I want to count the number of times it's equal true, and it would give me a bunch of false, true, false answers. But that's actually kind of the same thing as what I would get in the first place. So what I can do is I can use dispatch, and I'll say I want to sort a bunch of information based on how many true falses I had. So what I'm doing right now is I'm going to sort this list based on this list, which will give me, on one hand, all the trues and all the falses. This is a little bit hard to understand, but it's kind of a nifty trick. So essentially, I have 9 true values. If I click the button, I get 10, 11, 12. This is exactly what I want. And then if I count the length of the list, I get this kind of counter. So I'm going to reset it, and I click on the iterate button. 1, 2, 3, 4, 5, 6, 7. This is great. I'm getting a little counter. This is wonderful. And then I can reset. Now resetting makes it null for some reason. And if I click on it once, it turns into 1. So let's also add like a failsafe. Or not a failsafe, just a kind of a default, so that I'm going to merge this stream and this stream so that it always has a true value in it no matter what. So then if I empty it all together, it starts at 1, goes to 2, 3, 4, 5, 6, 7, 8. I could also subtract 1 from this length. Whoops, use the number 0. And that would make my counter start from 0, 1. Whoops, I should subtract 1. It would make my counter start from 0, 1, 2, 3, 4, 5, 6 over here, which is what we want because lists in Grasshopper start with 0. And in fact, this is a little messy, so what I'm going to do, and by messy I mean when I look at this, I don't immediately know what's going on. I'm going to grab all of this. I'm going to make it into a cluster that just says record to index, or I say record to counter. Actually, that's a little bit more expressive. Record to counter. Great, so now we have this cluster component that will iterate from 0 to onwards based on how many times we click the button. Now, remember this portion where we're using the list item and we're using the first point, the second point, third point, fourth point. Now you can imagine that if I plug this counter into here, instead of using the slider, I can just move which point my model is on. You can see that it's moving over here alongside a table, and this is great. And if I click again, it wraps around because of this item wrap index is true. Now the problem with this is great, but I also want to leave behind a version, and what I want to do is I want to bake that grasshopper geometry. Now in the SpiderStack example I might have explained this, but there are a few ways you can do this. Lunchbox has a bake component. Lunchbox, you can also download it, it's another plugin. There's also a person called Giulio Piacentino, who now works for Rhino. Giulio Piacentino, Grasshopper, who has a bake attributes component. It's on this page, Grasshopper Tools in C#, and so you can go to it, and you can find a bake attributes component. Now you can click on this, 0.82, the most recent version. You'll download it, and then you can grab what you've downloaded and drag it into the Grasshopper window. And you'll get this example, but really what you want is this at the end. So I'm going to copy. I'm going to paste back in here. If I paste, it's shown up somewhere, and I'm going to drag it. And so what this essentially does is, given a bunch of inputs, say objects, names, layers, and an activate toggle, it'll bake the Grasshopper geometry with a certain color. Now in this example, I've already done this over here. I've already set this up, but I'll do this again because you haven't seen. So first of all, I have to choose what I want to bake, and the bake attribute is actually very similar to the custom preview attribute. The custom preview component, which you should be using all the time. The custom preview component receives as input a geometry item and a shader or a color. And essentially, these all don't have to be filled, but this also takes in an object and a color, or a geometry and a color. So what I want to do is I have this thing, which is this analysis right over here. I need to move the floor height a little bit. And instead of this preview, including to this, I'm going to plug the objects and the colors in similarly. Excellent. Now, I'm just going to demonstrate this for you. If I plug in a toggle to activate and I click true, and I go out of it, and I close Grasshopper, I have actual geometry. You can see I can click on this. I can't click on the wires, but I click on the actual geometry. This is real. This is real. And I'm going to undo the bake. So this is kind of what I want. What I also want is I also want the kind of outer bounding box of it, and I also do want the wires. So I'm going to copy and paste this again, and then I'm going to grab the display object. This one, you can see, creates the kind of the volume of the geometry with a given transparency. And this I like, so I'm also going to take this and copy what inputs have been plugged into here. The colors, and this preview grabs the objects from here, so I'm going to input the objects over here as well. And lastly, I also want the wires, not the city, but the wires that are being used to illustrate the mesh. So that's this one. So I'm also going to copy and paste and get another one over here. Plug the shader object into the colors, and plug the resulting geometry into here. Excellent. So now I have these three bake attribute functions that are all plugged into this Boolean. And I'm actually going to clean this a little bit up by using a Boolean component. I plug this into the Boolean, plug the Boolean into the activate component. And if you're noticing why this disappears, it's because this is set up. If you right click, you can choose the wire display. So default is our normal version. You can choose faint, which is slightly hidden, or slightly thinner and more transparent, and hidden, which it exists if you click on it, but when you don't, you kind of see this kind of radiating antenna-esque symbol, transmission-esque symbol that's really connected to here. So now what I'm going to do is then I'm going to select this and move it down over here. And maybe you can see where this is going, but I want to activate this baking every time I click on this button. So I'm going to connect this into here. And this is actually not going to work on the first try, but I'll show you why and we can talk about it in a second. So if I click on it, I have baked, but where have I baked this? Well, first of all, I've baked this geometry over here. Second of all, I've baked the geometry over here into my new spot. And this is all wrong for many reasons. I'm going to undo. And I'm going to solve the question of moving that initial geometry. What I really want is I want to move, I want to bake this geometry over here. Excellent. So now if I try out that button, great, now you can see that it's baked around the new, onto the table. But the problem is, that's not what we wanted. We wanted it to bake and then to move over. Now the reason why it's doing that is the moment we click it, it's changing this data, and this changing this point, and then the baking is going to bake onto that point. So we want this to trigger before this triggers. How do we do that? There's this function called data dam, which delays data. So I'm going to create a panel and show you what this is doing. Here's a slider. So I'm going to set this to 0.25 seconds or 0.5 seconds. So there's a slight delay. If I change this to 10, it'll move to 10. If I change it to 0, it'll change to 0, but there's a little delay. If I set it to 2 seconds, if I move this slider to 8, I need to wait a little bit for this to change to 8. So this essentially delays something firing or a message coming through. So I can set this to say 1 second, and instead of the slider, I'm going to feed it this button, which means that when I click it, click the button, this won't change for about 1 second, and hopefully that's enough time for the geometry to bake before it's moved on. Actually, sorry, that's the other way in which we want to do this, because we want to bake first and then move second. So what I'm going to do is I'm actually going to put it over here. So that we can send the signal to the item counters later. So that it goes through, it records the data, processes the data, but then it sends the counter data a little bit late. So it bakes first and sends the counter data late. So if I click on it, it's baked and then it moves. And now you see that happening. And whatever it's baked, it's pretty opaque and I can't see inside. So for the time being, I will, whoops, I'm actually going to disable this bake function because for some reason the alpha channel isn't quite working right. So I'm going to disable this one. Okay. So now you can imagine that I go over here and I move some geometry around. And then I can click this button and it bakes and it moves over to the next point. I'm going to clean my script a little bit up by hiding everything that's not being used. And I'm also going to turn the camera sync back on. And I'm going to maximize Rhino. So now you can see what's going on. I have this table on which I am making geometry. And the type of geometry I'm making is being analyzed and shown, and I can change the floor height. Let's say over here I change it to have something that's pretty dense. And let's say I also decide that I would kind of like it for my geometry to touch the ground. Let's try that again. I think the copy didn't quite come through. Excellent. So I could say, oh, that's interesting. I'll iterate onto that. So I've baked it and I moved over. And if I look over, you can see there's my geometry. So, now I'm kind of continuing. Well, this is nice, but let's say, oh, I need more of a void. So I'll grab that dot and I will say, move it over. Is that more of a void? And let's say, oh, that's interesting. And I can iterate onto it. I've baked and moved over. And so now, while I'm designing, I can see what I did before and kind of compare and contrast. Say, okay, I need more of a floor plate, and so on and so forth. Again, my computer's a little slow because the screen recording software I'm using seems to be an incredible memory hog. But I think you get the general point of the idea. And this is kind of fun, so I'll click on iterate again and grab another version. Now, the nice thing about this is, again, I'm seeing progress. I'm seeing past and previous progress. I can make many different versions and kind of save them and showcase them. And I'm also doing a kind of representation, so I can very easily export this or kind of review my kind of previous processes. And I think oftentimes when you're working with parametric, so-called, or kind of tool-based architecture or design processes, that's one of the major downfalls or the kind of disadvantages is that you're busy moving the sliders around, that you're not sure what you did before, and it's a little bit hard to record progress, which is too bad. And this way is both a tool to represent and a tool to create. You get the idea. And so if you play around with the table a little bit more, you can get this kind of view. And then if you turn off Grasshopper altogether, and if you also turn off the timer, then you can later get this kind of table on which you've placed a lot of different models. And I think this kind of analysis is pretty interesting. For one, it's something that we're used to doing in physical models, but being able to display objects like these on a table is kind of like the sync camera tool or the custom preview. It won't change the tool itself, or it won't change the operation of the tool. The spider sack thing here is ultimately the same, but it really does change what you see and what you're doing. So for example, as I iterated, I realized that all my objects were flat side down, pointing side up, so I turned it upside down. That was only really possible because I was kind of comparing between all of these things, and I can continue to see through this kind of data analysis, color coding, what I've been doing, which is to say, oh, I've been making all these holes or apertures. Maybe I should be doing some other kind of strategy. So this is one way in which, and you can imagine taking a screenshot directly, or a make 2D won't be that bad. You can imagine even rendering this out in V-Ray or something, or incorporating into some other workflow in order to work within representation. So strategies like this is exactly, I think, something to think about in relation to how the tool represents itself. What is it showing? What kind of data is it showing? What kind of geometry is it showing? How is it showing the data that it's showing? Is it color coding or is it comparing? And how can you contrast these things together? How can you think about either lines or weights or emphasis? Because with all forms of data analysis, the crucial point is that there are certain forms of data, certain conclusions to make. In this, I've created this form and I've done this analysis. And I'm highlighting the yellow bands in which maybe there's a lot of different programs possible. Maybe the yellow bands, for example, assume this is, say, a mixed-use office building. The yellow bands are a kind of open plan office area, and the reddish bands are kind of smaller, programmatically different areas. And it's through this tool that then I can start to play with a new possible formations. For example, let's say my building wanted to be an office commune, and I wanted large open areas surrounded or connected by smaller private areas. This is exactly the kind of an analytic tool I would want to use in order to easily visualize and represent that kind of program.